Okay, on page 34, we're getting ready for the flame test lab so that next class we will be able to start with fire. Okay, but first, okay, are you going to sing or are you going to listen? Hush. Okay, we have to get ready for the flame test lab by going through the stuff on page 34. In the upcoming flame test lab, we will observe the colors produced when compounds are introduced into a flame. Today, we're going to focus on the chemistry of this amazing phenomenon. First, we need to talk about the ground states. Electrons are in their lowest energy state in the ground state. The ground state means it's the lowest energy. Ground like your lowest energy. Okay, a ground state electron looks normal. For example, lithium in the ground state is 1s2, 2s1, and we can draw those arrows in the way we've been doing. That's lithium in the ground state, where everything is normal. What does the word ground state sound like it means to you? What do you usually act like if you're in your ground state?
Asleep.
Tired.
Maybe asleep or tired. Okay, whatever it is, there's not a lot of space here, so you can just write me like 2 or 3 words, but describe to me, how do you usually act in your ground state? And then, what time of day are you usually in your ground state? Like your lowest energy state. Lowest energy. Okay, so write that down. It's probably the end of the day, or maybe when you first wake up, that's when you're at your lowest energy. Okay, that's different from the excited state where you have added energy. The excited state is when energy is added. Okay, children, you should not be talking, you should be writing. Luis, Cameron, Kyle, you should not be talking, you should be writing. When energy is added, an electron jumps up into a higher energy orbital. Okay, this makes the electron configuration look incorrect. Like lithium in the excited state, it could be 1s1, 2s1, 2p1, where one of the electrons has gained energy and jumped up to a higher energy state. So this one's in its normal spot, this one's in its normal spot. But one of the electrons has jumped up to be somewhere new. It's excited. It's excited.
Why is it excited? What picture is it?
It gained energy. 34.
So why did it turn the lights at the bathroom?
It could be that it's been hit with some high energy light, like a photon of high energy, like a gamma ray or an X-ray. Okay, it could be that someone has heated it up and given it some energy that way, but it's gained energy. Have you, do you guys know what bioluminescence is?
Yes.
Okay, bioluminescence is when certain organisms, is when certain organisms give off light. They glow. Okay, and there are organisms like plankton that can glow, and the way they do this is during. Okay, hush.
Isn't a lot of it reactive?
Well, yeah, but this is the reaction that happens.
Like the reason?
Yeah, so like the plankton will be floating along in the water.
This is in Puerto Rico.
I'm actually thinking of a place in the Cayman Islands, but I'm sure it probably exists in Puerto Rico too. But the plankton will be floating along and a fish swims by, and the fish makes the plankton think, oh no, there's a predator. And they glow to warn each other and to try to attract a bigger predator to come eat this other fish before the fish eats the plankton.
Oh, that's awesome.
Okay,
There's like
yeah.
this little cave and like the water just glows.
Yeah, there's a
at night.
bay in the Cayman Islands that does that too. And you can swim in it and it like glows while you're swimming. Okay,
Awesome.
the way that happens is during the day, the plankton are photosynthesizing, they're absorbing energy from the sun and they're turning it into food. But some of the energy, instead of turning it into food, they use it to excite their electrons so that their electrons have extra energy. So they take light from the sun and that gives their electrons extra energy. And then at night, when a predator swims by, the electron can fall back down to its ground state and that gives off light.
Wouldn't that be like the black thing that you give light and then once you turn the lights up it becomes...
Like glow in the dark stuff?
Yeah.
Yeah, that's how that works.
What if we could glow?
What if we could glow? You'd probably be sick. Okay, so when you're in an excited state, you usually have a lot of extra energy. And the kinds of things that make you go from your ground state into your excited state are like, I was going to say just like caffeine or sugar. Yeah, Red Bull.
Red Bull.
Okay. So let's do, okay, not drugs. If you need me to call the social worker to tell them about how you have a drug problem, I can. But if you don't have a drug problem, maybe you shouldn't be talking about
I was just
drugs.
giving an example of energy.
Caffeine. Okay. The ground state is when the electron configuration looks normal. Kyle. We know something's in the excited state when it has gained extra energy and it makes the electron configuration look broken. So if you look at at part A here, 1s2, 2s1, 2p3. Does this look normal or does it look broken?
That looks normal.
1s2, 2s1. What's broken? The 2s1. Yeah, what should this 1 be if it were not broken? It should be a 2. That's a clue that this is excited state. That's a clue that it's the excited state. David, do you have a question? Okay, part B, 1s2, 2s2, 2p6.
Oh, wait, no.
That's all normal and correct. That tells me it's the ground state. Okay, for part C, 1s1, 2s2.
Yes.
What's broken about it?
1s.
The 1s1, that's broken. That 1 should be a 2 if it were correct. That tells me this is the excited state. And for our final one, 1s2, 2s2, 2p3,
GS.
these all look correct, so that is the ground state. Okay, now this chart at the bottom,
Couldn't you do the same thing where you find the last one in the column unit that's in?
if it's in the ground state, that would work. If it's not in the ground state, that does not work. Okay, so the ground and excited state's going to work the same for these. We're like, this one is in the ground state because all of it looks good. This one, something looks broken, so this is the excited state. How are you going to tell what element it is?
Periodic table.
If it's in the ground state, you can use your periodic table by checking like, oh, 2p5, what element's the fifth one in the 2p. But if it's in the excited state, that's not going to work. To find what element it is when it's excited, there's only one thing you can do. What can you do if it's in the excited state? Kyle, what can you do if it's in the excited state to figure out what element it is?
Casey. No. That looks... No.
Like what? Put in the numbers? What numbers?
Those glasses.
Kyle, I want you to actually answer my question.
I don't know.
Oh, do you think that's because you're not paying attention to me?
Or because you're excited yet.
Well, I've talked about it before, last class. Satyan? Yeah, if you use the superscripts, those count the electrons. So if you add those up, 2 plus 2 is 4, plus 6 is 10, plus 1 is 11, plus 5 is 16 electrons. If there are 16 electrons, what element is that?
How did you get
I added up the electrons from these superscripts. Yeah. So Kyle, if you know there are 16 electrons, Kyle, if you know there are 16 electrons, what element is it?
Sulfur.
Yes, it is sulfur.
I found this cup. Do you need it?
I think it was hers. Did you ask her?
Yeah,
How do you find it out?
Then you can, I guess if she doesn't want it, you can trash it. If you add up all the electrons from the superscripts, there are 16 electrons, and element number 16 is sulfur. Yeah?
Wait, can you go up? Like, can I see the up?
Wait, we release sulfur?
Finish that chart at the bottom. Finish that chart at the bottom. Huh?
We release sulfur?
We what, sulfur?
We release sulfur?
That's time to leave.
The sulfur is releasing energy. The sulfur, gained energy to become excited, it will release energy when it goes back to its ground state.
Nope. People keep turning the lights off at the bathroom. Anytime
Okay,
soon.
I don't want to talk about the bathroom right now because you and I need to talk about that later and about how you were gone a lot longer than you were supposed to be and how you were not actually in the bathroom. We're going to talk about it later. Not right now. We're going to talk about Sebastian. We're going to talk about it later.
So I got work at 5, I work 20
Do you hear me
minutes.
saying we are going to talk about it later? So when I say later, that means later.
Are we still gonna do page 35?
We're keeping going. Go to the next page, page 35.
Oh yes, it's
Okay.
English.
We have to draw some stuff. How many electrons does lithium have?
Sorry.
How many electrons does
Isn't
lithium
what
have?
makes the Note 7
3. That is not the question I asked, Sebastian. So draw lithium's 3 electrons. This is a ground state. Shh, gentlemen. This is a ground state lithium atom. All the electrons are where they are supposed to be and their lowest energy level. Okay? If you add energy, like by adding fire, heat, or like a UV light, a black light, then one of these electrons can gain energy. So like if the electron gains some energy, if you shoot some energy at it, that can make the electron jump out to a higher energy state, further away from the nucleus. Garrett, do you have a question? David, did you have a question? Casey, did you have a question?
You said a statement.
Right now we're not saying statements because we're trying to finish before the bell rings, and I thought you guys wanted to actually be able to do the lab next class.
Are we doing
Then you need
it?
if you hush, we're almost done. But we still have to finish.
Yes, ma'am.
Finished one.
Okay? Then, if that electron gives off that extra energy and falls back to its ground state, when it gives off that extra energy will be light. And sometimes it will be different colors of light. When you're done drawing this, turn the page.
Uh-oh. Wait,
Didn't you say all the way to page 35? So I mean,
36.
I thought you said 35.
yeah, you said 35.
We need to get at least the top of 36 done.
You only said 5 pages.
No, 6.
One of them we had already finished. All right. Different energies of light can be different colors. Okay? Remember all that great stuff about waves? Different energies of light have different wavelengths, and our eyes perceive those as different colors. So, they've given us all these different colors, like red light has wavelengths between 750 and 620 nanometers. Those are longer waves. Whereas if you get all the way down to violet light, those are wavelengths between 440 and 380, and those are much shorter waves. We need to take these nanometers and convert them to meters, and the way to do that is dividing by 10 to the 9th. So take out your calculator.
So 750 minus 620 and then.
No. This is a range. This is not a subtraction. This is a range. So what we're doing is we're doing 750 divided by 10 to the 9th is 7.5 times 10 to the negative 7th. That's the first part of our range. And the second part of our range,
Where it's just not to the power.
what?
You just put like a 9.
Just let it finish. Just let it finish.
Yeah, you need the arrow up.
You need to write the scientific notation.
Yeah, I don't know how to
I
put
got
the
negative
power.
8.
In your calculator, just type 750 divided by 10 to the 9th.
Miss,
Yeah,
I
I
got to the
don't
power.
know how to go to the 9th power. It's
Just-
under-
It's above the division sign.
He said,
Look.
You mean the second?
Miss, I got
750
negative 8.
divided by 10. Hit this caret button,
Negative 8.
okay,
That was my question.
and then 9.
Thank you.
Yes.
He said negative 8. Garrett. Oh, yeah.
Okay, and 620 divided by 10 to the 9th would be 6.20 times 10 to the negative 7. Notice that this one is ending in the same place the next one is starting. That means this number and this number are going to be the same number.
I can't hear the group next to me.
Oh, so you used to divide both numbers? That's the average?
Yes. Well, not the average. We're not averaging.
But you divide?
Yes, you will take each number and divide by 10 to the 9th.
You divided by 750 and 620.
You divide 620 divided by 10 to the ninth, and then you do 590 divided by 10 to the ninth. Okay, David, why don't you go back to your seat? Obviously, this is not working.
And the B.
David, move. Back to your seat. Hush.
Guys, it's not Christmas.
Not even
That's a good song,
Halloween yet.
It really is.
Okay, you know what else would be really great?
The bell ringing.
If you
Oh,
finished
yeah.
your charts. Garrett, what is 570 divided by 10 to the ninth?
I do not know.
Where's your calculator?
Not with me.
Why don't you use the one on your phone?
Because that is too much work.
You say you can't use our phones.
Oh.
I'm giving him permission so that he can calculate this.
5.70 times 10
I can't break
to the
laws.
negative 7.
Wait, yeah.
I was correct.
Cameron was correct.
Correct. Yeah.
Get right.
Okay, what are you telling me? All you have to do.
Someone just had a conversation with himself.
Okay, 520 divided by 10 to the ninth is 5.20 times 10 to the negative 7. Are you guys seeing a pattern here?
Yes.
Yes, more and more numbers.
Yeah. It just gets me bored.
More and more numbers.
Oh my god.
Oh, you're going really fast.
Yeah, well, maybe you should get on my level.
I'm on the move.
Why would I want to step down?
Oh, he said why would he go down?
So it'd be 500 times 10?
Yeah, but this 500 divided by 10 to the ninth is 5 times 10 to the negative 7.
No, I'm gonna be sincere with you. All those science I've learned since like I was a baby. I've never used it again.
I'm
I
sorry to
only use
hear
it to
that.
pass tests. and
Sebastian.
then Forget about it.
I'm sorry to hear that. That's not what I'm doing right now. When you are done writing this, I want you to keep in mind, we are supposed to do a lab next class that involves fire, so you need to be prepared. That means if you have hair long enough to go in a ponytail, I will make you put it in a ponytail, so bring a rubber band. Okay, if you wear shoes that have your foot exposed, you don't get to play with fire. So make sure you have shoes. Make sure you have shoes that cover your whole foot. Okay? If you finish writing this, you can put your books away and the calculators away. Put away the calculator.